This video is sponsored by PCBWay. Hi, my name is Mark and I'm the electronic engineer. Welcome to another video about spectrum analyzers and ways to build them. The project I'm about to share with you is nothing other than amazing. It includes a Teensy microcontroller that drives two displays simultaneously at very high speed. Combined with a Teensy Audio Board, we will be able to do a frequency analysis of audio in real time to create a stereo spectrum analyzer of 69 channels. Yep, you understood that correct. 69 channels in stereo, so that's actually 138 frequency bins. On top of that, we will be displaying a stereo VU meter on a second display. So more or less we are really dealing with 140 channels. Did I already say that it's really super fast? Before we continue, let me say that this design was built on a previous release by DIY Lab, who created some amazing firmware and application. The link to his website is in the footnotes and please check it out, he does some amazing things. Also a great thank you to Arvind Sain for creating an amazing display driver and helping me getting it bug free. It is high time for you to build your own spectrum analyzer. As I already built several different versions, you have a bunch you can choose from. Because let's face it, every man cave or she shed needs one. Now, without further ado, let's get on with the build. So the whole idea of the spectrum analyzer is to drive two displays at the same time. So let's start with drawing two displays. We have display number 1 and we have display number 2. Then the heart of it all is a microcontroller board called a Teensy, and I'm using version 4.1, which is very important because we need to add external RAM, and I choose PS RAM that will be soldered onto the board. Of course, the microcontroller will communicate with both displays, and we'll also add an audio board, which will actually be used to do the actual FFT analysis of the audio. This board gives us an option for some really fast real-time FFT analysis. And the audio board has a microphone input and a line input, and it has a line output, and we can choose whether we want to use a microphone or the line in. Then of course we have the infrared sensor, so we can use an infrared remote control to operate the whole unit. It's an option, of course. We have one switch to control some functions, and I added a second switch. And in short, one switch will be used for selecting the input signal, and the other one will be used for the mode. Then of course I added some extra additional potentiometers, or at least the option to connect them at a later time. It's not implemented in the software yet, but the idea is that later on we can use them to set a delay, a sensitivity, maybe a brightness, and well, who else knows what. I also added two outputs for pixelettes. You can use a WS2812B or similar, and any compatible pixelettes will work. You can use a matrix or LED strips. And the idea is that I will use one for an extra spectrum analyzer display, and the second one will be used for illumination. It does nothing else than showing a rainbow mode. So you can give your acrylic housing a specific color. And that's all there is to it. This is the twin visualizer. And the schematic looks exactly the same as the blocks I just explained. It has a Teensy controller board, an audio board, 2 displays, and then we have some input devices and connection for pixel LEDs, and of course it has an onboard power supply. If you have any questions, don't hesitate to ask me. The link to the schematic is in the footnotes, so you can take a good look at it. Now first let me show you the microphone response. As you can see, it's very sensitive to microphone input. Now let me just flip this over so you can take a look at the PCB backside. Let me just disconnect all so we get a better view. Of course we have the Teensy board. We have the audio board. We have a microphone input, a line input, a line output, some options for pixel LEDs and potentiometers, and of course you have an onboard power supply. And an infrared input, so you can use an infrared remote control if you connect it to a sensor, of course. Now let me take out the Teensy controller to show you the backside. And as you can see, all the way to the left there's a little chip added, which is the external RAM that you need to add for this to work with 2 displays. Don't go anywhere, there's more after this.
You want to make a cool looking project using some electronics, but they often end up looking like this, or like this. Fortunately, there is a way to make them look very professionally and economically. You can do it with PCBWay, whether it's a school project or a professional grade project. PCBWay has all the services you need to create your project at the best price. Look at all the options they have. PCBs up to 14 layers with different base materials like aluminum and copper, flexible PCBs, SMD stencils, component assembly, and they even offer services like CNC machining and 3D printing, which is amazing.
Now let's look at a demo of what this unit can do.
So you